Hello Year 7s. In this video we're basically going to extend on what we did in the last section 1.05 where we looked at turning a worded statement into a mathematical statement. So taking words and turning them into numbers. So in this case we're going to do the same thing, but now we're going to be adding the contextual element. So basically we're taking a full worded question, working out what the statement or the equation should be so that we can then solve it at the end. So we're taking it to that next step. So looking at the lesson, here we go. We can again see this tree of operation and words that mean those operations that we saw in the last section. So again, if you haven't got a copy of this or a similar list, you might like to do so because they're going to be really useful. So we're going to scroll down a bit further and we won't go through this worked example. You can have a look at that yourself if you'd like to. We're going to jump straight down and have a look at the 3 sample questions that they provided at the end. So let's have a look at the first question. Again, I'll be using my sketch pad to write the answers on the screen for you here to demonstrate how I'd like you to solve these. So let's have the first question. On Grace's farm, there are 7 horses and 5 chickens. How many animals are all together? So this is where it's an extension of what we did last time, where they might have just had 7 and 5, and we had to work out what the statement would be. Now it's part of a fully worded question. So first of all, we have to work out what is in the question. So they're talking about 7 horses and 5 chickens. So 7 and 5. So we could write those numbers down right now if we wanted to, a little bit like the last topic, 7 and 5. Now we're looking for a word that helps us to understand what is happening to these numbers. And we saw the word and. And if we look at our list of words, or mathematical words from earlier, we will see that and usually means addition. So 7 and 5. So we're going to turn this into a plus. We can also tell this because the second part of the worded question says how many animals are there all together. And again, all together often means addition. So we are now looking at an equation of 7 plus 5. And of course we can now work out what that equals, and that will be 12. So I would be expecting this sort of working out in your book before you then came back to the question like I'm about to do and type your final answer in. Just the number 12 is all that Mathspace is expecting, but I do expect to see this working out in your book. Let's try that. And of course we are correct. So let's close that example and we'll have a look at the second one. So again, I just have to scroll down and we'll try the second problem. So in this one it says, I scored 4 goals in my netball match. Amelia scored twice as many as me. How many goals did Amelia score? So there's a few things we have to look at here. We know how many we scored. So again, let me get my sketch pad. We scored 4 goals. We know that Amelia scored twice as many. Twice is an important word, and it wants us to find out how many Amelia scored. So if Amelia scored twice as many as us, that means she has 2 lots of 4, the 4 that we scored and twice as many. So we could do this equation in 2 possible ways. We could say 4 plus 4, that would be twice as many, but a more efficient way would be a multiplication. When we say twice as many or something as many, we usually mean a multiplication. So in this case, it's probably better to do 4 times 2. So again, we'll just cross this one out for the moment. And remember that multiplication, the order of the operation or the numbers doesn't matter. So this could be 2 times 4. It's exactly the same thing. And of course, we would be able to solve that and get the value 8. Okay, so we're looking at the values, the numbers that we know. So in this case, the 4. We're looking at this part that talks about twice as many and the fact that we are looking for Amelia. So we are looking for the equation or the statement that gives us the twice as many. So twice meaning 2 times, which is how we get this statement here. So again, once we've solved this in our book, we can come back and put in the answer that we are looking for and submit that to see that we are correct. Let's have a look now at the final tutorial question. So let's try that problem here. It's quite a bit longer, so we're going to have to do a bit of extra reading and really take our time to see all the values that we might need. So let me get my sketch pad. The number of motor accidents in a particular intersection was reported by traffic police to be 73 last year. So here's a number, and I'm going to underline it to help me remember where it is. The local council then decided to put up warning signs for motorists approaching this intersection. So that part of the sentence doesn't really have any important information for us. It's just part of the story, if you like, of this question. The following year, the police reported only 24 accidents. Okay, so there's another number, we'll highlight that so we remember. How many fewer accidents, so there's an important word, fewer, were there after the signs were introduced? Now, fewer is going to indicate a subtraction. We're looking for a number that is less than it was before. So we had 73 originally, and then the next year we have 24 accidents, okay? Fewer would indicate a subtraction. We're trying to find out what the difference is, or the subtraction, to find out how many less accidents there were. So 73 minus 24 is what we're looking for. Now, because this is double digit numbers, we should really do this in the vertical algorithm. So let's do that. 73 minus 24, keeping everything nicely lined up, our line underneath, and our subtraction symbol. Remembering that subtraction has to be done in the right order. You would not get the same answer if you did 24 minus 73. Completely wrong. So 4 from 3 doesn't work, so we're going to borrow from up here. So that's going to become a 6, and we put our 1 there, which is now 13. So 4 from 13, of course, is 9. And then 2 from 6 leaves 4. Draw a line underneath to show that you've found your final answer, and that's what we're looking for. So again, you might start by writing it out like this as you're working out what the expression or statement is, but because this is double digits, I would like to see you do this as a vertical algorithm in your book. Okay, so I'd like to see this final example here. So let's see if our answer is correct. So we're going to put in the number 49 and submit that. And again, we were correct. So in each of those cases, the process was pretty much the same. Even the equations weren't any real different, but what we saw is the question length, if you like, the wording got a little bit longer and a little bit more complex in each of these. So we had to spend a bit more time as they went down, really carefully thinking about the question, looking for the numbers, looking for the words that indicate what operation is happening, and then making sure we wrote a good statement that we could then solve to give a final answer. So as I said, it's really an extension of what we did in the previous section where we started looking at writing statements, mathematical statements, from worded statements. This is now taken to the next step where it's a little bit more detail, and we're also now looking for an answer in most cases. So hopefully you'll find this one reasonably straightforward. As always, if you're having issues, you can watch the videos provided by Mathspace themselves in these tutorials, come back and reread any part of this lesson itself, and of course you're always welcome to ask your teacher, especially if you've had a genuine go yourself. Good luck with this. Remember to do the questions that have been assigned to you, and if you're looking for additional work, please speak to your teacher.